Hello everyone. In this video, we are going to take a look at current commutated chopper. So let's get started. This is the circuit diagram of a current commutated chopper. If you carefully observe, we are using a thyristor T1, which is actually used in chopper circuits or DC-DC converter circuits. Whenever we are using thyristors, we need to turn them off externally through some means if we are using a DC power supply as the source. If you are having an AC power supply, automatically T1 will be turned off due to natural commutation as the supply will go in the negative direction as well. But in this case, we need an external circuit to turn off thyristor T1, and that is done through the additional circuitry that we have considered over here. The way in which we are doing that is basically we're going to charge the capacitor C, and through the capacitor current, we will turn off the thyristor T1. How we will be doing that is something that I'll be explaining in detail as we go further in this particular video. TA is basically an auxiliary thyristor which will help in the process of commutation of T1. Now let's consider an equivalent circuit which is similar to that of the circuit diagram. Here what we are going to do is we are going to close the switch that was open previously over here. So once the switch is closed, we are not going to trigger T1 or TA or any other devices in the circuit. So what is going to happen? The capacitor is going to charge with a polarity plus and minus, isn't it? So the current starts flowing only through this path and the capacitor charges to a maximum voltage of say equal to Vs. So this is the first and foremost step that we do. Now let's continue our analysis. So we are going to divide this into various time instants starting from 0 to T1, and we are going to parallelly draw the equivalent circuits and correlate with the concept of waveforms so that it will be very easy for us to understand the circuit operation and draw the waveforms as well. The waveforms basically contains gate current, that is IG1, current that is going to be supplied, or the gate pulse that is going to be supplied to thyristor T1. IGA is for the auxiliary thyristor. IOUT is basically the output current. IC the charging or the capacitor current, and IT1 is the current flowing through thyristor T1, and VC is the voltage across capacitor, and Vout is the output voltage. So now what we are going to consider is we're going to supply some gate pulses. If you're starting at 0, I'm going to consider some gate pulses at some instance for us to understand the circuit operation. We are assuming the output current, basically the load current, to be continuous in nature. This is basically an assumption because when we are using thyristors in choppers, we will try to design it to have a continuous output current. So this continuous output current will help us to make our analysis much simpler, and we'll be able to understand it in a much better way. So 0 to T1 is the duration that we have considered in this case, isn't it? So 0 is the point where I'm going to give a gate pulse to thyristor T1, meaning to say that the thyristor T1 is basically acting as a short circuit because I have provided a gate pulse and positive supply is given to T1, negative is reaching the other end of the thyristor T1. So the thyristor is entering into forward conduction mode and acting as short circuit over here, isn't it? So now what happens is that the current starts flowing from the source in this direction through thyristor T1 to the load in this particular direction through this path, and then it returns back to the source over here. So what happens to the nature of all these waveforms? If we consider these parameters for drawing the waveforms, it's more than enough. Main focus will be on IT1 because the current through the thyristor, whenever it is going to 0, that is when the thyristor is actually turning off, isn't it? So what is the nature of capacitor current? The capacitor current from 0 to T1 is basically 0 because the capacitor is not discharging, isn't it? It's not discharging through any of the paths over here. Consequently, it is acting as a zero current path over here. So the capacitor current is 0 as it's not discharging through any of the circuits that is considered in this particular case. Now what is the thyristor current? Thyristor current is basically equal to I naught because the same current is flowing from the source to the load. So IT1 will be equal to I naught. It is the same current as they are connected in series from this point to this point. So it's basically I naught. It's following the I out waveform. What is the capacitor voltage waveform? the voltage across the capacitor is basically equal to Vs because we had previously charged it to a polarity say equal to plus minus Vs, isn't it? So the voltage across the capacitor is Vs, so it will be following the supply voltage. So whatever is supplied will be appearing across voltage Vc, so it will be equal to Vs over here. Now what is the output voltage? Output voltage is also equal to Vs because you're connecting the source directly to the load, basically through means of a short over here through thyristor T1. So whatever you're supplying will be available at the load terminal. As a result, Vout will be equal to Vs in this case. I hope this point is clear. Now let's continue our analysis. What happens from T1 to T2? Again, let's consider the waveforms as where we had left previously. And T2 is some instant that we're going to consider in this particular waveform. Say at this point is where we're considering T2. Now again, let's consider the circuit diagram. If you carefully observe from T1 at this point, we are going to trigger the auxiliary thyristor as well. So we are going to trigger the auxiliary thyristor. Basically, we are providing a gate pulse to auxiliary thyristor over here. As a result, it is acting as short circuit because positive supply is anyways connected to auxiliary thyristor, isn't it? So consequently, what is going to happen? The capacitor that was charged to plus and minus, it will keep circulating through this path. This is basically an LC tank circuit, isn't it? It will be an oscillatory circuit. So the energy in the capacitor will start going into the inductor with a polarity plus and minus. The inductor will start charging. Again, the capacitor energy will go to inductor and the inductor will reverse its polarity. Again, the capacitor keeps charging. So this process I will explain. But in general, this is basically an LC tank circuit, which is an oscillatory circuit. It keeps charging between the capacitor and the inductor over here. So what happens to the nature of IC? So IC basically will have a sinusoidal kind of a waveform because of the oscillatory nature. Because the energy in the capacitor is going to the inductor and again the energy in the inductor will go back to the capacitor, and through that it will reverse its polarity. Meaning to say plus is available at this point and minus is available at this point. Again in the next cycle what will happen once the inductor is completely charged, it does not allow sudden change in current. It will reverse its polarity to plus and minus, and again it will act as an energy source, and the capacitor will charge with a polarity minus and plus in this particular direction. So this keeps repeating. So it's basically a sinusoidal pattern that will observe. As a result, we will have a decreasing capacitor current as the inductor is charging. Again, an increasing capacitor current through this particular path. I hope this point is clear. So what happens to thyristor T1? So the thyristor T1 current will remain the same because this is short circuit. So whatever is available at this point, it's basically an open circuit at this point, isn't it? There is no current flowing through this path. So whatever is available will keep going through the load. So it's basically connected in series. As a result, IT1 still will have IOT as the current in this particular case. What happens to the voltage across the capacitor? The voltage across the capacitor will keep decaying again through this particular fashion because the energy in the capacitor is going to the inductor. Again, the cyclic process repeats, but we will continue as we go from T2 further. But in general, the capacitor energy that is stored is going to the inductor, and the inductor builds up a magnetic field around it. Again, the inductor will give the energy to the capacitor, and that's why we are showing it at the decreasing nature here. What happens to the output voltage? Output voltage again it's connected in short. If you see, the current flow will be through this pattern. So the source is directly connected to the load. If you're measuring the output voltage at this point, it will be equal to Vs, whatever we are supplying. So it's continuing in this direction. Now let's continue our analysis and see what happens from T2 to T3. Again, I've considered T3, say it at some instant after T2, and we will again consider the equivalent circuit. So from T2 to T3, what is happening is we saw that the capacitor is negatively charged to the inductor, isn't it? The polarity of the capacitor is reversed. So consequently, what will happen is that negative is connected to the thyristor, auxiliary thyristor TA, and hence it's acting as open circuit. Previously, it was short circuited because we had given a gate pulse to the auxiliary thyristor. But since negative is connected to this point, what is happening? The short circuit has become open circuit because we are giving a negative power supply to the auxiliary thyristor. So this is through a natural process. Due to the presence of inductor, we are able to turn off the auxiliary thyristor. So now what will happen is that the energy that is stored in the capacitor will start flowing through this path, and plus is connected to the anode of diode D2. Till this case, what was happening? Always D2 was reverse biased, but now plus is directly connected to the anode of diode D2. As a result, the current will be flowing through this path. It will flow through this path, and then it will flow through thyristor T1 and then return back to capacitor C over here. We also have another path of current that is through T1 from the source to the load. We see the current flowing through this path, and then it goes to the load from the source to the load. So now one important observation: IC is the capacitor current, IOUT is the load current, IT1 is the thyristor current. Our main objective here is to ensure that IT1 becomes equal to 0. That is when thyristor T1 will be turned off, isn't it? The anode current through the device should go to 0 for the SCR to turn off. So what we are doing is IC is flowing in the opposite direction, meaning to say, what is IT1? It is basically the difference between IOUT and IC. So some amount of capacitor current is flowing in the opposite direction. So that's reducing the thyristor current that is flowing into this particular circuit. So that's what I wanted to mainly emphasize here on. So now let's again take a look at the waveforms. What happens to the capacitor current? The capacitor now, the current through the capacitor is flowing through this path, and then again the oscillatory nature, because of the oscillatory nature through the inductor, again the energy is coming through this path through this direction, and the capacitor is again charging, isn't it? So what is happening is that the capacitor current is flowing in the opposite direction because the polarity of the capacitor is reversed compared to the previous case. I hope this point is clear. Now what happens to thyristor current? It keeps increasing to a point, the capacitor current keeps increasing to a point where IOUT minus IC will become equal to 0. So that is the point at T3. So basically the capacitor keeps increasing to a point when IC is equal to IOUT in the waveform, the current through the thyristor will go to 0 at T3. So that's why you're seeing a decreasing slope over here. What happens to the capacitor voltage? Again, the capacitor voltage starts building up over here. You don't have any discharge path, it's just circulating through this particular loop. As a result, it's almost constant through T1 to T3. And what happens to the output voltage? The output voltage is still the same because the source is connected to the load through thyristor T1. As a result, you're getting V out to be equal to Vs again. Now let's continue our analysis. What happens from T3 to T4? Again, we have considered the waveform and we have considered T4 to be at some point. So now what happened was, previously the capacitor current was flowing, isn't it? So it was charged with a polarity, say minus and plus, and it was flowing through this path. Because the thyristor current is going to 0, basically we are ensuring that IT1 will become equal to 0. As a result, the current through the thyristor, that is T1, will become equal to 0, and it acts as reverse bias because there is no anode current that is flowing into the circuit, isn't it? You're basically reducing the current flow through the thyristor T1 for it to ensure that it goes to reverse bias condition. As a result, thyristor T1 is becoming open circuited in this case compared to that of the previous circuit. So what will happen now? The current still flows through this path, through this path, through the diode, because till the case when T1 was conducting, T1 was ensuring D1 is not conducting. Once T1 is open circuited, the plus polarity will directly appear across the anode of D1. As a result, it's getting forward biased, and consequently it's ensuring that T1 does not turn on because of the forward voltage drop that the diode D1 creates. So the current starts flowing through this loop, and there is no flow of current through T1 direction. The current will flow only through the capacitor. The source current will flow only through the capacitor through this path to the load in this particular direction, and it reaches this point. So what is the nature of the capacitor current here? The capacitor current starts discharging through the load as the current is flowing through this path through the load. As a result, you're seeing a drooping shape till this point. What happens to thyristor current? It is gone to zero, so it's actually open circuited, so no current is flowing through the thyristor, so the thyristor current is zero over here. What happens to the voltage across the capacitor? Again, if you carefully observe, the capacitor is discharging through this path, and again at some point it will keep charging in the reverse direction because of the power supply, because plus is directly connected to this point. Once the capacitor is discharged, it will charge with a reverse polarity, that is plus and minus. So because of this action, you're seeing an increasing capacitor voltage from negative to the other end of the positive voltage. Now what happens to the output voltage? The output voltage will still be constant because the supply is still connected through the capacitor in this particular direction, because the Vs is given through the capacitor in this path. Now what happens from T4 to T5? Again, let's consider T5 to be some instant in the waveform, and we have drawn the previous waveform till where we have considered, that is till point T4, and we are going to again consider the circuit. So the capacitor was previously charged with a polarity plus and minus, isn't it? So in this case, what will happen is that the current will still be flowing through the capacitor, through the inductor, through the diode, to the load in this direction. But since, if you carefully observe, plus is connected to the cathode of D1, hence D1 is becoming reversed bias. Basically, D1 which was conducting previously will act as open circuit, and there is no flow of current through path T1. So the current is flowing only from the source to the load through the capacitor in this direction. I hope this point is clear. So now what is the nature of the capacitor current over here? If you carefully observe, capacitor current is equal to load current because the same current is flowing through the capacitor to the load. In the previous case, it was not the same because some amount of capacitor current was flowing through the diode D1 as well, isn't it? So as a result, now they are connected in series. As a result, the capacitor current is just following the output current over here. Now what happens to the thyristor current? It is still zero because it is acting as open circuit, so it's considered to be zero from this point. What happens to the capacitor voltage? Again, the capacitor voltage is charging through the power supply Vs in this particular case, and it's still reaching to some extent where it will become completely equal to Vs. So it's just shown for an drooping increase from this point to this point. What happens to the output voltage over here? The output voltage is decreasing from this point to this point. The reason is because the energy that is stored in the inductor in the previous cycle, what it does is it will forward bias the freewheeling diode. Basically, if the capacitor voltage is sufficiently large enough for it to forward bias the thyristor, that forward bias the freewheeling diode over here, because minus is connected through this path to this point. So if the voltage across the capacitor is sufficiently large enough for forward biasing the freewheeling diode FD, then in that case the freewheeling diode will act as short circuit. So because of that, you see a decreasing nature in the output voltage because it's going to go to zero at T5, and that's the reason a decreasing nature is shown over here. Now what happens from T5 to T6? Again, let's consider the equivalent circuit. As I mentioned, the the freewheeling nature, because of the load as well as the capacitor voltage that is reverse biasing the freewheeling diode at this point, what happens is that the energy that is available over here just keeps freewheeling through this path and keeps circulating. So there is no flow of energy from the source to the load in this particular case. As a result, freewheeling takes place due to the freewheeling diode that is available at the load terminals. So from T5 to T6, if you carefully observe, the capacitor current is going to zero because there is no current flowing through the capacitor in this case. So what happens to the thyristor current? Again, it's zero because it's acting as open circuit. There is no flow of current through the thyristor. Again, capacitor voltage has reached a point say equal to Vs just to show an increasing nature, it's just slightly drawn so that it reaches a point Vs as in the previous case. And the output voltage will be 0 because if you measure the output voltage at these 2 points, it's basically a short circuit over here, isn't it? So this short circuit will have an output voltage say equal to 0 volt. So that's why it's going to 0 over here. Now the time duration T1, T2, T3, T4 and T6, T5 and T6 can be controlled by the values of the capacitor, inductor and the charging resistor RC. All of these values will largely influence the nature of the duration at which the thyristor has to turn off. So I hope this video gave you a clear understanding of current commutated chopper. In case you have any questions, feel free to reach out by typing in your questions in the comment section below. Please do give your valuable feedbacks in the comment section and like the video if you really like this. Thanks a lot. Stay tuned. Thank you.